Uh, yeah. Hi everyone. Really happy to see you here. So we'll see, can ChatGPT really solve web data extraction, and in general, what large language models are capable of, and how to use them in this space. My name is Konstantin, and in the data science team, we are building products which use machine learning to get the web data. And obviously, this topic is really fascinating and interesting, and as everyone else, we started playing out with it and watching what others are doing. And when ChatGPT came out, I was really surprised to find out that it is actually able to do a decent job at doing extraction of product attributes if I just give it the URL and some attributes to extract. And the reason why I was surprised was that, it wasn't supposed to browse the web. Like, how does it do it? And I tried it on a few different URLs, like some Amazon, iPhone, so on, and it worked. And after a bit of trial and error, realized that what it does is that it is able to guess, by looking at the URL, it is able to guess what kind of product is hiding behind this URL, and then generate the description. Like here, this is a books to scrape website, so it must be a book, and then there is a light in the attic in the URL, and which is a real book. Which it knows about. And so it realizes, under this URL there is a book, and in fact it is generating a description of this book which is much better than what is given on the website, and it is able to output that. So it's nice in a way, but it's not what we want here, because we want to extract the actual data. And now if you try the same, at least it's being honest, it says, no, sorry, I can't do that. Yeah, which is correct, but again, not what we want. And finally, if you happen to have plugins available and happen to have the browser plugin, which might not be yet in the EU, you would be able to actually have it browse the page and answer the question using the content of a live web page as extra information, and then it would finally do the extraction of the live data. So does it solve web data extraction? I would say not quite. What is missing? So for one, this browser plugin and plugins in general are not available in the API yet. And then if we were to download the page ourselves and give it to OpenAI, then the page would be typically much larger than what we can input into the model. And finally, for any real system, you need to also do the crawling, you need to collect the data, and then if you start processing every page with a large language model, the cost can just become absurd. Like in the previous talk, we were talking about petabytes of data, and here you would be, it would just be impossible to imagine how much it would cost. But given all of those problems, why do we even care? Why are we excited? So I think since large language models can understand text, it makes them really helpful in two parts of the problem. So one part is that the user can usually describe the data that they want in a quite short textual description of what they want, and large language models can understand that. And the second part where they are really helpful is that web pages are made for humans and they mostly consist of text, and large language models can understand this text. So basically they can understand what we need, and then they can understand, they know how to do it. So if we could just magically connect these two things and build on top of them, that should do the trick. Now, what exactly do we want? Ideally, what I would want, I want to enter some description, high-level description of what data I want from what website, what fields, maybe some details, then throw it into some system, and then the system gives me back all the data, and then I can check the data, maybe tweak the description slightly to better represent what I wanted, and get finally my clean data back. And it's easy to see how this would be really valuable for both people who want the data and also for companies who provide the data. And there can be some other approaches to this. For example, in e-commerce, we can see that typically we can identify that people want a certain set of attributes, let's say 20 most popular attributes, and then we can build a traditional machine learning model which would be trained to extract these attributes. And this can work in a way, but what we're seeing is that In many cases, people would want some extra attribute or two which fall outside of this core schema and which requires some customization. So every project, every customer is different, and if we do customization for every project, then yeah, it becomes like it's no longer automatic. And yeah, to further focus us on just data extraction, like let's forget about the crawling for now. Like the crawling is also difficult, but if we figure out extraction, the crawling is easier to build. And let's say the user supplies us with description of the attributes they want. And here, let's think of jigsaw puzzles where we assemble some picture, and the customer is interested in the number of pieces and the location which is shown on the puzzle. So maybe it's some castle in Ireland we're assembling. And yeah, as you see, these two attributes are really concisely and rather precisely explained here, but they are definitely fall out of any standard schema, and they would be non-trivial to extract both with classical ML and even with like traditional spider development. Now that we have the problem, let's look at the tool. Like what can LLMs do? Like, yeah, they are large language models, so they work on text, and we put text as input, and this text, they are able to understand it, and they're able to understand instructions in this text. And then they output some text as well, so only work with text. One constraint is the size of the input, so for current models, it is like a few thousand words typically, and which yeah, immediately means that some web pages would be very large. We need to think about this. And another constraint is cost. So they are extremely expensive, whether you buy them, whether you run them yourself, they're extremely expensive to process. So you need to think, how do I limit the processing time? And also the best models are still commercial and hosted by third parties, so you can only call them via API, which means that you should be fine by sending your data to a third party if you were to use a commercial model, or you need to invest in your own models. And yeah, like given all those constraints, we can see how do we design this and what design decisions can we make, like how do we represent web pages, how do we input web pages, what kind of output do we ask for, and then what kind of models do we use. Like regarding the input, so like web pages, yeah, like the most natural representation of a web page is just its HTML source, which tells us, yeah, what content there is and also how it looks, and would often contain some, maybe the data in a more structured format as well. And like on one of our e-commerce data sets, if we measure the size of the page in terms of the number of tokens, like the average would be around 150,000 tokens, which is much larger than a typical context size of a large language model. And we can clean HTML, like remove some styles, remove some scripts, which we're pretty sure won't be needed. This brings us down 2x, but which is still too big. Now, if we were to take only the text of the web page, that would be already much smaller, like let's say 5,000 tokens, and well, like already this fits into this, we can put that as input into the model. But then there is one more trick we can do. Let's say, again, we're thinking about e-commerce, like the product website, besides the product, it has a lot of other stuff, like it has some navigation menu, it has some footer, it has related products, it has a lot of stuff. And identifying the core of the page, which is really meaningful for us, is easy, and it can be done the same regardless of what kind of attributes you want to extract. And so we can, for example, train a lightweight machine learning model which is able to find the most interesting bit of the page and take the text just from that bit. And this brings another improvement, which brings down the input size to, let's say, 1,500 tokens on average, which is already quite tractable. But the cost still, I mean, it brings 100 times, even more than that, reduction of the cost, because also longer contexts are slightly more expensive, so it's non-linear. But still, the cost looks quite high. And so when we think, okay, how do we solve this? Like the first idea which comes to mind is to generate the code. This means that instead of applying the large language model on every web page, let's take one web page and then, or a few of them, and then generate the code which would do the web scraping. And this code would then be run efficiently and cheaply, and that would scale really well. I don't think current models are yet at the level where we can just ask them to generate the whole code and run it blindly. But for web data extraction, it is quite a specific task, not some generic programming task. So it's specific, and we can structure it, and we can ask for CSS or XPath selectors for like elements which are on the page, and this selector would tell how to extract this element, and then we'll maybe apply some post-processing on top. And yeah, this is how it can look like. So we input the HTML. So we need to input HTML. We can just input text, because in this case, like we cannot generate selectors without the HTML. And then we ask nicely to generate some selectors. And this is an example of GPT-4 working on this books to scrape website with its full HTML, which is quite small. And it produces like quite nice CSS selectors. Like, they are not perfect, like a human could improve them, but important thing is that they are correct. They work on this web page. Yeah, so that's great. Like, one big issue is obviously the size of HTML, so we'll need to think of an intelligent way of cleaning this. And so I think this works really well. This works really well for demos and for proof of concepts. But once we start to apply this in the real world, I think there are some issues here. Like, yes, it's fast, it's cheap, and we can check if the code makes sense. But I think in practice, like, websites have multiple layouts, and these websites can change. So we need to think, okay, how we detect these different layouts? How do you decide which extraction rules to apply, how to detect the change, how to update this. So this is quite a big stateless system now. And yeah, and I mean, it makes sense, because in a real scraping project as well, writing correct selectors is only a small part of the overall challenge. And yeah, all the rest stuff on top adds a lot of complexity, and we still have this complexity here. And finally, another drawback here, I think, is that we're missing on the most powerful features of large language models, that, like, selectors, they don't cover really all use cases. Let's think of the puzzles again. Like, we have this website, like a part of the website describing a jigsaw puzzle, and the number of pieces is in its own HTML element, and selector might not be pretty, but at least it would be possible to extract. But the location is inside a larger text field. And if we were doing this project like in a traditional way, we would either send the customer the whole text field and tell them to deal with it themselves, which is not nice, or we would say, okay, we need to think how to do this. So maybe for this location, we can use some gazetteer, we can use some address extractor, or maybe build some lightweight model to do this. But this needs custom thinking, custom development for every attribute we extract. But with a large language model, we can just ask it to do this. So we input the text of this web page, and then we tell it, please extract. And it doesn't care about the HTML elements. It sees the text, and it is able to extract a part of the text. But even besides that, it is even more powerful, because it can not only extract a part of the text, it can also generate text. And once you start thinking in this like paradigm, you can think of many interesting attributes that you can extract. For example, you can ask, please extract a 3-sentence summary of this article. And this 3-sentence summary, like I just described it here, and LLM would be able to understand it and execute on it. And suddenly, without any extra development, you have like article summarization. Or you can tell it, let's say you're crawling job postings and you're interested in what positions are remote, which are on-site, and which are hybrid. And this would be expressed in a million different ways on different job posting websites, in different ads, or maybe it won't be specified. But then you can, again, write a short description of the attribute you want, give it to LLM, and then it will be able to give it back. So yeah, this enables things which would be really hard to do in a traditional way. And yeah, this is easy to implement, stateless, and I think it is also robust enough to be used in real projects. Like we're already seeing it, that there are projects where this enables us to do things which were really hard without it, and it is robust enough. And obviously, it is really expensive to run. And when we're thinking about the costs, yeah, like one thing which comes to mind is like, can we reduce the cost? Instead of calling a third-party service, let's try to build our own stuff. And like have some self-hosted models. And so another advantage is that they can be used with more sensitive data. We can send it maybe personal data if we don't store it, and they can be made cheaper to run, and we control them better, we can reduce the latency. So this is all very good, so they can do all of this stuff, but it is not easy, like because all of this stuff is new, and for example, like can be cheaper to run, but if you just take off-the-shelf model with a reasonable quality and run it, you will see that it is actually more expensive than ChatGPT. Like ChatGPT is priced really competitively, and to actually make a model, your own model, cheaper to run requires some investment in choosing the right runtime, investing in infrastructure. So unless you have enough volume, it won't be cheaper. And like, again, handling, let's say, personal data, yes, if you don't store it, you're fine. But for example, if you want to fine-tune your model, you cannot fine-tune it on personal data because then personal data becomes a part of your model and you cannot remove it. And so this gets really complicated. And finally, the quality, like there is this quality gap. So ideally, you want to fine-tune your model on a more specific task. So because of all of those, I would say that my recommendation would be to start with prototyping with a commercial model, like OpenAI, Google, or someone. Like with OpenAI especially, we have these functions where you can define a set of functions the model can use, and it would output, like it can output a function invocation, which is a really nice way to give model output structured data and interact with it. Yeah, interact with it in a structured way. And then you can see, okay, can I solve this problem? Does it bring value? What model quality do I need? Let's say, can ChatGPT 3.5 solve it reliably, or do I need a better quality? What are the ballpark costs? And then if everything works out, then you can check if, yeah, replicating it with open source models would make any sense. And yeah, like this is an approach we're following with this custom attribute tag. So we started with just seeing, okay, yes, it works. Then we saw that like even GPT 3.5 can reach enough practical quality and good costs for certain internal projects and can allow us to do things which would be really hard to do otherwise. And I also think that this is like a paradigm which is slightly easier to start in, because it allows us to do things which weren't possible before instead of making things which were possible before cheaper. So I think it is always an easier sell to do something which you couldn't do before than to do something for cheaper, because, yeah, like it becomes cheaper only when it's good enough. And so, yeah, I want to share like a little demo of this where we do the custom attribute extraction. And yeah, the reason I want to share this is because, yeah, on the next slide, I will give access to this demo so that you can try it out yourself. And yeah, like we're looking for feedback on like what you think about it, what use cases you see. So let me just show it. Like we can enter a URL, let's say this books to scrape website, and yeah, the first step, so it's working only on text, so it would run download the page via Zite API and then extract the main part of the text from this page, and in this case, it results in a very small bit of text. And then we can tell it, okay, what attributes do I want to extract? Let's say I want to extract the price. And then also it is possible to add like description, let's say SKU. I would say, so I need some product ID like SKU or maybe UPC. And then we, based on this description, we run the extraction, and it is generating the result. And then also just test how robust model is. I can maybe edit some stuff in the text and maybe change the UPC as well, and rerun the extraction again, just to make it easier to explore what are the failure cases, what are the issues with the model, and see the updated result. And so there is this give feedback link. You can tell, we know it's not perfect, so it's very early preview, but obviously a lot of stuff is not working and we're improving quality, but still, I mean, would be interested to give you, to hear your feedback, what would you use it for, what works, what doesn't work. And to get you started, there are a few examples which are more comprehensive, where we have a pre-populated text and a larger set of attributes to extract. And so we can try them out. And as you'll see, there are some errors it is making. That's so the access. And it would also, one other thing I wanted to mention is that how it works with personal data. So we don't want to extract, don't want to allow extraction of personal data. So let's say if I extract the author of this book, right now it would conservatively assume that author is something which we don't want to allow extraction yet. So it will be filtered out, and it will tell us that. The access is here, so you can try it out. So the address is LLM extraction demo, and the username is extract summit, and the password is extract summit 2023. And we'll keep this access up until next Monday. So thanks a lot, and looking forward to your questions and to your feedback.
There's one or two questions here. I think this stuff is extremely interesting. This is obviously an early preview, of what we're doing. It's going to be in early 2024, incorporated into some of our products, so, coming soon. But let's go for this. Yes, I was going to ask this question, the whole area of hallucination or quality. Do you want to maybe speak to that?
So hallucination, that's a great question. I think one of the first things comes to mind. So there are a few things there. So one is with what we see, for example, when we started testing, we see that GPT 3.5 is quite prone to it. So it would, I don't know, maybe in, I think it depends. The most difficult bit is when you have an attribute which you want to extract, and this attribute is not present in the page, but still, I mean, someone can reasonably deduce that, okay, maybe this is the value of this attribute. And then ChatGPT 3.5 specifically can hallucinate. So what we saw is that actually our fine-tuned model, it is worse in following the precise instructions. So if you give a really elaborate description of what you want to extract, it is currently worse, but it is better at not hallucinating. So fine-tuning on your specific task reduces hallucination a lot. Another thing is, if you know that it is purely an extractive task, you can always do fuzzy matching of extracted value against the web page and understand, okay, if it's not there, then it's probably made up. Next thing is when you're doing sampling, prediction from the model, you can do, you can check the probability, or you can do consistency sampling when you sample multiple values for this attribute and check if they change, then this is probably made up. And lastly, we are also experimenting with a purely extractive approach, where instead of generating, we would be predicting a span in the document, and this is guaranteed to never hallucinate, but it is restricted to only extractive tasks, and it cannot generate, let's say, an article summary.
Okay, we have a question here about a specific open source LLM you could recommend?
So like we've been exploring a few of them, and like we're really liking the Llama 2 model because has relatively transparent licensing. We know what it was trained on, which is I think also important because, like for example, some of the newer models, like let's say Mistral, it is supposed to be better on benchmarks, but they don't release any details. Like it is supposedly open source, but it is just like some binary blob basically, and we don't know what it was trained on, and so it might be challenging to use it in a commercial setting for like to provide a product if we don't know, because maybe it was cleaned on something illegal or so it's a bit tricky. Can recommend the Llama 2 model, and I think one other thing is with the models to also when you test it out look at the tokenizer as well. Like does the tokenizer do a reasonable job on your data? Because, for example, like T5 family of models, they don't even understand the new line character. So for them, a new line is the same as a space, which like I guess makes sense for short text, but doesn't make sense if you have like a large web page where new lines might be meaningful.
Yeah, I think I like this one down here about the fine-tuning LLMs for particular use cases and segments and so on.
Oh yeah, that's a great question. Yeah, so actually the model which is there, it is only trained on e-commerce attributes, but what we saw is that it is able to generalize to other settings. Like there is one of the examples, I think one of the last, where we show how it works on job postings. And we also saw that it works on like people profiles. So basically, even without us yet extending the data set to more domains, it already was able to generalize to other domains. And so, yeah, that was quite surprising and nice about this. And yeah, we plan to keep one model for everything and just like teach it new things instead of having task-specific models.
Yeah, I'm not quite sure what the top question. So did you explore models which can describe images, i.e. screenshots
on
the website?
Yeah, so with GPT-4, with plugin, if you have images enabled, you can put screenshots there, and it works quite well. Like, let's say we can put a screenshot of the web page and tell it to extract something, and it would do a great job at this. I didn't compare quality per se, but yeah, the big problem is that this is not available in the API, and it's unclear if it would be available, what would be the pricing, because it might be like several times more expensive than GPT-4 already is, and then this is more or less a non-starter. And like internally, like some of the models which we use, like traditional ML models, they use the screenshot as well, and that provides a boost of quality, but surprisingly not that big of a boost. And so it is possible to do a decent job with HTML alone, and it is much cheaper to acquire if the website doesn't require rendering.
So the second one here about GPT-4 being 20 times more expensive than 3.5, do you think it's worth it?
Yeah, I think it depends on the use case. So I think one use case where it's totally worth it is, let's say, if you are generating code or like when you don't need to run it on every web page. So let's say if you have, especially if you're using it as an assistance, for example, you might use the GPT-4 generated code as a starting point for some web page and then tweak it later or ask it to tweak in a specific way. But yeah, invoking GPT-4 on every web page is almost never worth it because yeah, it becomes comparable with paying human annotators to do the same.
So the second one here about, is company data leakage a concern when using commercial LLMs for extraction?
Yeah, definitely. Well, I guess not for extraction. So I don't, like with extraction, I think like if you're using a third-party model, yes, obviously you need to think. So for example, in like at Zeit, we are not sending any personal data to a third party. So we won't be using like third-party LLMs to deal with any personal data. But I think a bigger concern is just everyone happily using ChatGPT and throwing like company code or personal data into it. And especially because like ChatGPT, unlike the API, ChatGPT would store this personal data and may use it to improve the models. yeah, so I guess that to me is a bigger concern.
So there's actually one here that I can answer. So are we going to incorporate, the LLM functionality into Zeit API? Yes, we are. So we're going to do that in a number of ways. So we will describe that later on. And as I said earlier, some of this stuff is going to come in early 24 is the current plan. There's a few things to sort out before we get to scale versions. Okay, so this question here at the bottom I think is interesting. So do you want to describe maybe the extraction framework, the tech, that the demo was based on?
Oh yeah, so this demo is built with Streamlit, which is like a popular framework for like doing quick little things. Yeah, it's obviously not super robust. Like with this particular demo as well, you might want to refresh it if you leave the tab open for a while. Yeah, but for quick demos, it works nicely.
And we'll take two more. So I'll go with this one here about are we implementing any open source language models such as Falcon?
Yeah, so I think I answered that before. So we're experimenting with Llama 2 and a few other models. We haven't tried. Well, I think we tried a bit Falcon, but not a lot.
And I'm just gonna.
Maybe can I take
the
top one? I think it's interesting. Yeah, so regarding how to clean this text for web scraping. So there are some good open source libraries for this. Like there is, like you probably heard about these libraries like newspaper, readability, stuff like that. And then there is another one, which is I think called Trafatula or something like that, which in our benchmark worked I think the best. So we did we posted an article extraction benchmark a while ago, and I think these libraries, like open source libraries, they can do a reasonable job on any kind of the page. So this is similar to like reader mode in Safari or Firefox, and there are good open source libraries which can give a good baseline. So I wouldn't recommend using a large language model, even lightweight large language model for this task, because I think it kind of defeats the purpose, because the purpose is to have something more lightweight.
Konstantin, thanks so much for that. Konstantin is going to be here obviously all day, so anybody in the room wants to talk to him. I think the link that we shared earlier with the demo and the trial, have a go at it. We really do want to have some feedback on your views on this sort of stuff. So the team is really active, promoting that. So thanks, Konstantin, as usual.